want to look at is from what we just proved now, product of polar form. What if we have the nth one? We want to multiply z1, z2, z2. Then it's going to take us to another interesting topic, which is called the Mobius theorem. The Mobius theorem. The Mobius theorem. What the Mobius theorem says is that if I have, let's say, z1, z2 to z raised to power n, or if I want to put it in a better way, if I have z1 equals, let's say we have r cos theta plus I sin theta raised to power of n. Or don't let me put the one. Let's say z is equals to r cos theta plus I sin theta raised to power of n. Normally, when my n is 1, we are going to have just a complex number. But when my n is 2, then we have 2. That is to multiply the two polar form. When my n is 3, we are going to have 3 to multiply the 3, like the one I showed you the other time. What if my n is 1000? Are you going to continue to multiply in that way? That is why this theorem, the Mobius theorem, comes into help. What the Mobius theorem says is that when you have this, instead of saying your r, which is your what, your resultant or your is raised to power n, then this your cos. You know, normally, okay, let me just say this before I go directly. Normally I can split this. This r is common to both cos and sine. Then this n can take that power, then I can have what, r raised to power n into cos theta plus I sin theta. Everything raised to power n. From here, since r is common to everything, then I can have r raised to power n. Now if I apply the De Moivre's theorem to this side, instead of me multiplying cos theta plus I sin theta, cos theta many times, then I can apply the De Moivre's theorem. Now the De Moivre's theorem will just be, this is r raised to power n into this, your n will come down. I'm going to have cos theta plus what, plus n. Sorry, I'm going to have n theta plus I sin n theta. That is just the De Moivre's theorem for this. What De Moivre's theorem says is that your power will just come down to come and multiply your what, your angle, and that's what we show. If you see that if you continue to add, you know, we have theta 1 plus theta 2 plus theta 3 plus and so on. But if your theta 1 is equals to theta 2 equals to theta 3, then we are going to have what, the end of that theta, and that is what De Moivre's theorem says. Now that is how to find. Now what if you want to find the root of a complex number? If you want to find the root of a complex number, if I have Zn raised to power n, this is the nth root of what, of the complex number. And how am I going to do this? It's also the Mobius theorem. And what the Mobius theorem says on this is that your z, which is r cos theta plus I sin theta raised to power of 1 divided by n, or 1 over n, then instead of saying what, z, my r can take the power like the same way we did here, r raised to power 1 divided by n into what, cos theta plus what, I sin theta, everything raised to power 1 over n. Now just the same thing, but this, because this is a fraction, and in your root, if you want to solve a question regarding root, you need to get, it depends on the number of your n. Your n will determine the number of root that you want to get. If you remember, when we are dealing with quadratic, we said we are going to get two roots. When we are dealing with polynomial of order 3, we are going to get 3 roots. The same thing to this. Now from here, the De Moivre's theorem here will now say z is equals to r raised to power 1 over n into, we are going to have cos theta plus 2 pi k divided by n. It's just like the same thing. This 1 over n will come down, but you must consider the rotation of the angle, because we are not going to get single root. You must consider the rotation of the angle. plus I sine theta plus 2 pi k divided by n. And this is the modulus theorem for finding root of the complex number. With this, you should be able to solve questions regarding to complex number. Also, complex number has a lot of application. We can use complex number to solve trig function. It has a lot of application. But before that, let's look at example of the modulus theorem. Let's look at example. Now, example. Find the square root. Find the square root of. Find the square root of root 2 minus I. Want to find the square root of root 2 minus I. Want to find the square root of root 2 minus I. Now, let's look at solution to this. Solution. Whenever you want to find square root or you want to find nth root of a complex number, the best thing is for you to take that complex number to what? To polar form. Now, if I want to take this complex number to a polar form, let me just call it z is equals to square root of 2 minus I. What did I need? I need to get my r and I need to get my what? My theta. Then, now from here, sorry, I can tell you from here, your k is integer. K is an integer. Integers. K is an integer. Positive integer. K is positive integer. K is positive integer. Now from here, I can say what? I need my r. And what is r? R is square root of what? S square plus y square, which is equals to what? Square root of root 2 square minus plus 1 square. And what is that? This will give me what? Square root of root 2 is still 2 plus 1, which is what? Root 3. This will give me root 3. Now we need to get theta now. Theta. We need to get theta. And if you want to get theta, you can use theta equals tan inverse of what? Y over x. Tan inverse of y over x. Now, if you want to get your theta, please, you must consider the coordinate that theta fall into. It's very, very important. Now, how are you going to consider the coordinate? Go and draw your cartesian plane and locate your value. Your y is negative and your x is positive. It means my theta will be in what? In this fourth quadrant. Theta must be in what? Sorry. Yes, theta must be in fourth quadrant because my y is negative and my x is what? Is positive. Theta must be in fourth quadrant. Let's see. Now, what is that? We want to get the tan inverse of what? We have 1 over 2. 1 over root 2. What is tan inverse of 1 over root 2? Tan inverse of 1 over root 2. What is tan inverse of? Someone should help me with tan inverse of 1 over root 2. Then if I get the tan inverse of 1 over root 2, just get tan inverse of 1 over root 2. If you get tan inverse of 1 over root 2, then you consider that it is what? Fourth quadrant. If you can leave the answer in form of pi, then you substitute. You now find the root. Your z1 1 over root 2, 1 over root 2, tan inverse of 1 over root 2. It's not a special angle. That is the problem. Yes, tan inverse of 1 over root 2 is not a special angle. But if I press my calculator, it's going to be around. Let's just give it a figure. Let's assume it gives me, let's say it gives me like 25. This 25 or 20 or something if it give me 25, this 25 is not the answer. I said your theta fall in what? In fourth quadrant. And remember, what is fourth quadrant? 360 minus theta. 360 minus theta, that is the first quadrant. Then I can say theta will now be equal to what? 335. If theta is 335, then I can substitute everything I need. Then I can say my z, if I substitute, my z will just be what? Root 3 raised to power. Since I need square root, my n is 1 over 2. Then it's going to be raised to power 1 over 2 cos 335 plus 2 pi k divided by 2 plus I sine 335 plus 2 pi k divided by 2. Now the two roots will be when k is equals to 0 and when k is equals to 1. When k is equals to 0, just put it here. Then I'm going to have, because of this, I don't have calculator with me. I will give you the answer in full. Just on your own, press the calculator. You are going to see that it is very, very simple and easy. We are going to continue from here in our next class. Well, as I said, you can finish it up with this question because I don't have calculator to press the angle. You can just check the angle, then you finish the everything. Now I want to solve question. Now I'm through with all the information you need with complex number for your level. Let me just say this: complex number or complex is more than this, but for 100 level you just need complex number. For those of us that will still continue mathematics in our year 3, we are going to do what is called complex analysis. Then from there you are going to apply all those concepts that you learn in your real analysis that you are going to be doing in your year 2 to complex analysis. That is, you are going to look at some terminology involving complex number or complex analysis. Now let's look at, I just want to solve some questions before I leave. All these questions are directly from your textbook. Pick your textbook and solve more questions. The first one, let's see, want to express, I'm going to write the question on the board. Express the 2 plus 3i divided by I 4 minus 5i plus 2 divided by I. Express it in the form a plus ib. That is the first question. The second question, find the modulus and argument of the following. A 2 plus 5i, B 3 minus 4i, C minus 5 minus 7i. The third one, let z1 equals root 3 plus I and z2 equals 1 plus I root 3 using the Mobius theorem or law to find the product of z1 z2. Number 4, if 2a minus b plus I 4a plus 5b equals 10 minus I, find A and B. The fifth question, if Z equals 2 cos 150 degree plus I sine 150 degree, find Z raised to power 4 and Z raised to power 1 over 3. Now let's solve this question together. Let's see if we can solve one or two. Now, the first one, I have solved this type of question before. It's just the same thing. What you just need to do, combine the numerator, the two sides. You can do it separately, rationalize the first part, rationalize the second part, the result you add it together. At the end of the day, you are going to get the result in form of the rectangular form A plus IB. That is just what you are asked to do. It's very easy. Just try it. I will not solve that because I will solve something like that. Now, the number 2 question, find the modulus and argument of the following. As I said, my R, the R that I showed the other time, which is equals to S squared plus Y squared. This R is what is called the modulus. This R is modulus. Modulus, or we call it of absolute. Modulus or absolute. Any of the two, they call it modulus or absolute. While your theta, the theta that we also get there is what is called the argument. The argument. Theta is also what is called the argument. And we have solved questions, but let me just solve one of the questions. As I said, it's very easy. When you have this type of question, your R from the definition, what is my R? My R, the first thing, I can draw the Cartesian plane for me to locate the exact point of the value given to me. If I'm solving question A, 2A, 2 plus 5, it means my X is positive, my Y is also positive. Then I will have something like this. My X is 2, my X is 2, let's say this is 2, and Y is 5. Then if I join them together, let me just say I have this will be my R, this is 5, this is 2. Then my modulo, which is my R, will just be R equals square root of what? 2 squared plus what? 5 squared. Then my R is what? Square root of 4 plus 25, which is equal to square root of what? 29. Why the argument? The argument theta will just be, you can use any method. Since you know your R already, you can use any of the so-called or the trig identity. But let me use tan. I don't want to use the R. I will have tan inverse of what? Y divided by X. As I said, I must consider the coordinate or the coordinate that my X and Y fall to, or the quadrant that my X and Y fall to. Since it's positive, it means the value of my theta will just be between 0 and 90, since it's positive. Then how am I going to get that? I will just have theta equals tan inverse of 5 over 2, which is tan inverse of what? 2.5. You can press your calculator. Tan inverse of 2.5. You are going to have your answer, tan inverse of what? 2.5. And that is what the argument. That is how to get the argument. When you're asked to find the argument, your theta is your argument, and when you're asked to find your modulus, R is your modulo. You can try the other one. 3 and minus 4. It means it's not going to fall inside this. 3 and minus 4 will fall where? My 3 is positive and minus 4 is negative. Then it means it's going to fall around here. I'm going to have this. My X is 3. My X is 3. And my Y is what? My X is 3, sorry. My X is 3. If my X is 3, then Y, which is negative, Y is what? Y is 4. And I can say this is also my X, which is 3. Then I can join. I can call this my R. It means the theta that I must get must be between what? My theta must be between theta less than or equals to what? 270 theta 270 is less than or equals to theta less than or equals to what 360 must be my what my argument. That is, any value of theta that I get, I must subtract it from here, from 360, because this quadrant is 360 minus theta. Any value of theta that I get must be between 360 minus theta. That is how to do the second one. The third one, negative negative, it means it's going to fall under what third quadrant, because your s is negative, your y is negative. That is how to tackle question 2. Now let's look at question 3. Let's look at question 3. Question 3 says what? We are given z1 and z2, and they ask us to what? Using the modulus theorem to find the product. I've also solved something like this before. If my z1 is equals to root 3 plus I, and my z2 is equals to 1 plus I root 3. As I said, what is the modulus theorem? You need r and theta. Leave your answer in product. Yes, product of this z1 z2, we have proved it before. What is that? r1 r2 into what? Cos theta 1 plus theta 2 plus I sine theta 1 plus what? Theta 2. This is what you just need. This is what you just need. What is your r1 and r2? You can get that. My r1 will be from z1, which is r1 will just be square root of what? Root 3 square plus 1 square, which is what? Square root of 3 plus 1, which is square root of 4, which is equals to 2. My r2 will be the same thing, 1 plus root 3 square, which is also square root of 4, which is also 2. Then we want to get theta, our theta. My theta 1 will just be tan inverse of what? Tan inverse of 1 over root 3, and which is equals to, this will give me 30, I think 30 degree. And my theta 2 will give me tan inverse of root 3 over 1, which is what? 60 degree. Then from here I can say z1 z2 will now be equals to 2 times 2, which is 4, into cos theta 1 plus theta 2, which is 90, 30, let me write 30 plus 60, plus I sine 30 plus 60. Then we have z1 z2 equals 4 into cos 90 plus I sine 90. That is my answer. Or you can write as 4 into cos 5 over 2 plus I sine 5 over 2. That is what you are expected to do. It is very easy. That is question 3. Question 4 and 5 before we go. Now question 4 is very easy too. We are given if 2a plus 2a minus b is my real part plus I 4a plus 5b equals 10 minus I. Then they ask us to find a and b. Very easy. What we just need to do, compare both sides. It means I can see the real part for this left hand side is 2a minus b equals the real part for the right hand side is 10. Call this equation 1. For the imaginary part, the left hand side is what? 4a plus 5b. And the imaginary part for the right hand side is what? Minus 1. Then this is equation 2. Then if I solve equation 1 and 2, I will see I can multiply my equation 2 by 2 by minus 2 and add. Then a will go. I have minus 2 times minus b will give me 2b. 2b plus 5b side 7b equals minus 20 minus 20 minus 1 minus 21. Then my b will be minus 3. If b is minus 3, then I can say what? 2a minus b equals to 10. Then 2a equals 10 plus b. We have 2a equals 10 plus b is minus 3. Then 2a equals what? 7. A equals what? 7 over 2. It means a equals 7 over 2 and b equals minus 3. A equals 7 over 2, b equals what? Minus 3. That is the solution to question 4. Very direct and simple. While lastly, I want to look at question 5 and we leave. Question 5. I've also solved question like this. Well, to make things easy, I've given z. Z equals the last question 2 into cos 150 degree plus I sine 150 degree. Then we want to find z raised to power 4, meaning 2 into cos 150 degree plus I sine 150 degree, everything raised to power of 4. Now I can say this is 2 raised to power 4. Then I have cos. This one will give me what? From the formula, 4 times 150 degree plus I sine 4 times 150 degree. At the end of the day, we have 2 raised to power 4 is 16 into, this is cos 600 degree plus I sine 600. And that is the answer. You can press your calculator to get cos 600 and sine 600 and you see the answer. Now for the other one, we want to get z raised to power 1 over 3, which is the last one. The same process. 2 into cos 150 degree plus I sine 150 degree, everything raised to power of 1 over 3. Very easy. Distribute it. 2 raised to power 1 over 3 cos, this is going to give me 150 plus 2 pi k over 3. Remember, plus I sine 150 plus 2 pi k over 3. For my k, the value of my k will be from, since I want to get the third root, the value of my k will be from 0, 1, 2. Will be my third root. The first one, when for z1, first root, my k will be 0. Then I have 2 raised to the power of 1 over 3 cos. If k is 0 here, I will just have cos what? 150 over 3, which is 50. 150 for k equals to 0. This is when k is equals to 0. 150 over 3 plus I sine 150 over 3. That is the first root when k is equal. When k is equals to 1, you can press your calculator. This one will later give me 2 raised to the power 1 over 3 cos 50 plus I sine 50. First root, you need to get 3 roots. When k is equals to 1, then substitute. I have z2 equals 2 raised to the power 1 over 3 cos 150 plus 2 pi k. 2 pi k, k is 1, we have 2 pi over 3. 2 pi is 360 plus I sine 150 plus 2 pi over 3. That is for that. You can press your calculator. 2 pi is 360. 360 plus 150 divided by 3, you find the answer. Why the last one when k is equals to 2? we have z3 will be 2 raised to the power of 3 cos 150 plus, that will give me 4 pi divided by 3 plus I sine 150 plus 4 pi divided by 3. This is where k is equals to 2. This is where k is equals to 2. And that is the solution. From your calculator, you can get the answer to this. All these questions are very cheap, and these are the questions you should be expecting in your exam. Just make sure you solve more other questions. Look for questions and solve. Pick your past question and solve. This is complex number. Please, you didn't do complex number in your secondary school. That is why I started with complex number. Make sure you understand the concept and read it very well. After going through my slide, you can pick your textbook. You should be able to understand other things you have in textbook. Solve the whole question at the back of the textbook. Pick your past question and solve. After all this, I know you have prepared for 10% of your course. That is 10 out of 100%. I'm going to be doing other topics later. After this complex number, I'll move to the other topic. But you can encourage me by make sure of what you go through this. You accept a video from me as the little one I can use to help you. See you guys in my next video.